Most developers first encounter security as a checklist, add a login page, hash the passwords, call it done. But security is not a feature you bolt on at the end. It is a quality that must be woven into the structure of your system from the very first design decision. That is what this video is about. Imagine a web app where all security lives in one place, the login screen. Once a user is past that gate, every layer of the system trusts them completely. If an attacker finds a way to skip the gate, or if a trusted insider goes rogue, there is nothing standing between them and your most sensitive data. Retrofitting protections after the system is built means cutting across every layer, breaking interfaces, and almost certainly missing something. Think about how a bank is designed compared to a nightclub. A nightclub puts all its trust in one bouncer at the front door. A bank treats every zone as a potential threat boundary. The lobby, the teller counter, the safe deposit room, the vault. Each zone has its own controls. That layered thinking is exactly the architectural mindset security requires. When you map security onto a three-tier architecture, every tier boundary becomes a natural enforcement point. The presentation tier handles authentication, confirming who the caller is, and rejects malformed input before it ever reaches business logic. The business logic tier enforces authorization, confirming what that caller is allowed to do. The data tier protects stored information with encryption and tight access controls. Each layer stands independently, so a breach at one does not automatically compromise the others. Follow a single request through the system. It arrives over an encrypted TLS connection, so it cannot be read in transit. The presentation tier immediately checks authentication. Is there a valid token? If not, the request is rejected before touching any logic. Valid input is sanitized to prevent injection attacks. The business logic tier then checks authorization. Does this user have permission for this specific operation? Only if both checks pass does the request reach the data tier, which stores and retrieves data using minimal privilege credentials and encrypted storage. The real cost of designing security is upfront time. You have to think about threat boundaries before you write a line of code. But that investment pays off immediately. Controls are explicit, auditable, and independent. Bolting security on afterward is tempting because it feels faster at the start, but you almost always end up with a fragile single gate, tangled interfaces, and gaps you will not discover until something goes wrong in production. The CIA triad, confidentiality, integrity, and availability, gives you three concrete questions to ask at every tier boundary. Can an attacker read data they should not? Can they alter it without detection? Can they deny access to legitimate users? When you threat model during design, before code exists, you can assign the right controls to the right tier, rather than scrambling to patch holes later. Run this check at every boundary, presentation to business logic, and business logic to data. Security is not a feature. It is a structural property of your system. When you place independent controls at every tier boundary, a single compromise layer does not mean total exposure. Use the CIA triad to ask the right questions early and treat each boundary between tiers as a deliberate enforcement point. The earlier these decisions are made, the less painful and more effective they will be.